Thanks. Mark Lapatsis, Evercore ISI. Thanks a lot for hosting the meeting. Really appreciate it. Jensen, you guys have made some announcements on quantum computing. Can you share with us your view on, how this technology develops over time, what your strategy is, and longer term, pick the time frame, 5, 10, 15 years. What is the difference between what quantum computing will be doing versus the accelerating computing platforms that you have? Thank you.
Sure. Quantum computing can't solve every problem. It's good at small data, big combinatorial computing problems. It's not good at large data problems. It's good at small data problems. And the reason for that is because the way you communicate with a quantum computer is microwaves. And it's, terabytes of data is not a thing for them. And so just working backwards, there are some very, very interesting problems that you could use quantum computers for. Truly generating a random number, cryptography. So these are problems that are small data, big compute. Working backwards, we're a computing company. We're an accelerated computing company. And as you know, we work with CPUs. We obviously build Grace. We're not offended by anything around us. And we just want to build computers that can solve problems that normal computers can't. And so in the case of quantum computing, it turns out that you need a classical computer to do error correction with the quantum computer. And that classical computer better be the fastest computer that humanity can build. And that happens to be us. And so we are the perfect company to be the classical part of classical quantum. And so we working with, just about every quantum computing company in the world is working with us now. And they're working with us in two ways. One, this quantum classical, we call it CUDA-Q. So we're extending CUDA to quantum. And they use us for simulating the algorithms, simulating the architecture, creating the architecture itself, and developing algorithms that we can use someday. And when is that someday? We're probably somewhere between, in terms of the number of qubits, order of 5 orders of magnitude or 6 orders of magnitude away. And so if you kind of said 15 years for very useful quantum computers, that would probably be on the early side. If you said 30 is probably on the late side. But if you picked 20, I think a whole bunch of us would believe it. But what we're interested in is we want to help the industry get there as fast as possible, and to create the computer of the future, and we'll be a very significant part of it.
Thanks, Jensen. I'm going to add my thanks for hosting the